integrate 1 over a squared minus x squared dx equal to 1 over a hyperbolic tan inverse x over a plus c. Derive. We need to show that that integration will give you this. So we can start the integration by doing the integral of 1 over a squared minus x squared dx. And I'm going to take the a squared out in the denominator, so that a squared over a squared minus x squared over a squared. I'm taking the a squared out, dx. This is 1 over a squared, so I'm going to bring it out here. 1 over a squared integral 1 over 1 minus x over a all squared dx. Because if I multiply a squared by the bracket, this a squared will cancel that a squared, I get a squared back, and this a squared will cancel that a squared, I get minus x squared back. And the next thing I need to do is to substitute by saying let x over a equal to hyperbolic tan theta, and therefore x will be equal to a hyperbolic tan theta. I need to find the x, so I need to differentiate these to get the x. The x equal to over the theta, a, if you differentiate hyperbolic tan, you get hyperbolic sec squared. Sec, hyperbolic sec squared theta. And then I need to multiply both sides by the theta. The x equal to a sec squared theta d theta. Now I need to bring these into there and then complete this. So let's write that to be equal to the integral 1 over a squared, and so I get my dx, which is this, a hyperbolic sec squared theta d theta over 1 minus, well, x over a is hyperbolic tan, so if I square it I get hyperbolic tan squared theta. But what is hyperbolic tan squared theta? Well, if I take sine squared theta and I convert it to hyperbolic sine, it will be minus sine, hyperbolic sine squared theta. But tan squared theta is sine squared theta over cos squared theta. So if I convert that to hyperbolic tan, because sine squared converted to hyperbolic sine is minus, so I'm going to get minus hyperbolic tan squared theta. And from identity equation, we know that tan squared theta plus 1 equal to sec squared theta. But converting that, minus tan, hyperbolic tan squared theta plus 1 will be sec, hyperbolic sec squared theta. And I've got that here. I've got the minus hyperbolic tan squared theta plus 1 here, and that will be hyperbolic sec squared theta. So I can carry on and rewrite this integration by saying the integral of 1 over a squared minus x squared dx can be written as, well, the a will cancel a, and this will be 1 over a integral sec, hyperbolic sec squared theta over hyperbolic sec squared theta d theta. And that can be written as, let's just draw a line here so we don't get confused, and that can be written as 1 over a integral, the two will cancel each other, delta theta. And that means there is 1 here, because that's 1 delta theta, which I can write as 1 over a delta integral of 1 delta theta, which is 1 over a, and that will be integral of theta to the power 0 delta theta. And when you integrate that using a integration formula, we shall get 1 over a theta plus c. That's using the integration formula for that. And we know what theta is. If I rearrange this, because I know that this is x over a equals to hyperbolic tan theta. Therefore, theta will be inverse hyperbolic tan x over a. By just converting that, making theta the subject. Divide both sides by hyperbolic tan. 1 over hyperbolic tan. 1 over hyperbolic tan is hyperbolic tan to the power minus 1. So I'm going to replace that here. So the final result will be that integration will become 1 over a hyperbolic tan to the power minus 1 x over a plus c. So the final result is that when you integrate 1 over a squared minus x squared dx, you will get 1 over a hyperbolic tan to the power minus 1 x over a plus c. And that is the final result.